Your drain is slow right now. Maybe it has been slow for weeks. You poured a bottle of Drano down it, waited 30 minutes, and it worked for about 10 days. Then it slowed down again, so you bought another bottle. That cycle is not bad luck. That is a business model working exactly as designed. There is a mineral that costs under $2 at any hardware store in America that dissolves the same grease, hair, and organic buildup faster and more completely than any chemical drain cleaner on the shelf. Not slightly cheaper, not roughly comparable. Measurably better for your pipe, long term, at a fraction of the cost. Roman engineers used it to maintain bathhouses serving 10,000 people every single day. Egyptian builders applied it in drainage systems 3,000 years ago. American frontier homesteaders used it exclusively before the first chemical drain cleaner was ever patented. The EPA confirmed its complete biodegradable profile in 1993. And the drain cleaner industry generates $2.3 billion every year, selling you a caustic alternative that quietly damages your pipes with every single pour. They did not bury this because it failed. They buried it because it worked too well, and you cannot build a billion-dollar repeat purchase business around something that costs 21 cents per use. Around 1500 BC, Egyptian engineers maintaining the drainage channels beneath the temple complex at Karnak used natron, a naturally occurring sodium mineral, to clear organic buildup from stone water channels. They did not understand the chemistry, but they could observe the result. Grease dissolved, flow resumed, and those channels stayed clear. Around 100 AD, Roman maintenance crews flushed the Cloaca Maxima, the world's oldest functional sewer system, with sodium-rich alkaline mineral compounds sourced from volcanic deposits near Rome, a city of 1 million people. Functional drainage for over 1,000 years. Same mineral, different continent. In the 1840s, American homesteaders on the Ohio frontier rendered lye from wood ash and poured it through cabin drainage systems every single season. Not because someone sold it to them, because their parents showed them and it worked. And here is the detail that matters. These three groups never met. They never read each other's texts. They were separated by thousands of miles and thousands of years, and they all arrived at the same alkaline solution. That is not coincidence. That is fundamental chemistry patiently waiting to be understood, and now waiting for you to use it. For generations, alkaline mineral compounds were common household knowledge, freely shared, openly practiced, cheaply purchased. Every grandmother knew, every homesteader used it. Then the mid-20th century petrochemical industry arrived, and they did not do anything illegal. They did not need to. They simply looked at what people were already doing for free and asked one very profitable question. Now, what if we could sell them a branded version of the same result? Packaged, marketed, and engineered with just enough of a flaw to guarantee the customer comes back next month. That is not a conspiracy. That is just business. The problem is that in this particular case, the natural alternative already existed, already worked, and already cost almost nothing. So the branded version did not need to be better. It just needed to be louder. Bigger shelf placement, television advertising, bright orange bottles at eye level in every hardware store in America. The mineral got pushed to the laundry aisle. The knowledge of what it could do for your drain got quietly left behind. What cannot generate recurring revenue cannot be allowed to spread. Welcome to Forbidden Camping. I'm Hunter Lawson. If you're not subscribed yet, hit subscribe and the bell right now. This is where we dig up what the outdoor, survival, and homestead industry buried. And today, we are going very deep. Stay with me. The year is 1500 BC. Somewhere along the eastern bank of the Nile River, inside the sprawling temple complex of Karnak, the air is thick with incense smoke and dry desert heat. A maintenance engineer, not a priest, not a pharaoh, not a nobleman, crouches beside a stone drainage channel running beneath a ritual washing chamber used daily by temple workers. The channel is blocked. Organic matter, fat residue from food preparation, and mineral deposits from Nile water have built up along the interior stone walls and reduced the flow to a trickle. He does not send a messenger to a supplier. He does not mix an experimental compound. He reaches for a clay vessel of natron, the same white crystalline mineral used in the embalming chambers across the complex, dissolves several handfuls into a pot of heated Nile water, and pours it slowly and deliberately through the channel opening. Then he waits. Within the hour, the fat residue coating the stone walls begins to break apart. The organic matter softens, the mineral scale loosens, flow resumes. The ritual washing chamber remains fully operational. The engineer records nothing about molecular chemistry. He records only the result. It worked, again, as it always had. What this engineer was triggering, without any knowledge of chemistry, was a process modern science would later name saponification. The high alkalinity of dissolved natron converts fatty acid chains into water-soluble soap compounds that rinse cleanly through any channel or pipe. The same alkalinity denatures protein-based materials, hair, organic debris, biological residue, by breaking the molecular bonds holding them together. The Egyptian engineer did not need the word. He had the observable result. And the Ebers Papyrus, one of the oldest preserved household management texts in human history, dated to approximately 1550 BC, documents natron's cleaning applications in exactly this context. Archaeological excavations at Karnak have recovered ceramic storage vessels near drainage infrastructure containing natron residue, catalogued by the Egyptian Antiquities Organization. Now cross an ocean and move 1,400 years forward. The year is 100 AD. Beneath the streets of Rome, the Cloaca Maxima, the world's oldest operational sewer system, first constructed in the 6th century BC, handles the waste output of a city of 1 million people. Roman maintenance engineers faced the identical problem the Egyptian worker faced 14 centuries earlier: grease accumulation, organic buildup, drainage failure, threatening the infrastructure of an entire civilization. They source a sodium-rich alkaline compound from volcanic mineral deposits in the Italian countryside, chemically near identical to natron, and flush it through the system in large volumes during seasonal maintenance cycles. The Roman engineer Vitruvius, in his foundational work De Architectura, written in 15 BC, references mineral-based washing compounds in public infrastructure maintenance. The Cloaca Maxima remained partially operational for over 1,000 years. Part of it still functions today, a 2,600-year-old drainage system maintained in part by the same alkaline chemistry this video is about. Stay with me, because what a frontier chemist stumbles upon in 1846 in a Cincinnati laboratory changes everything we thought we knew about who actually owns this discovery. Before we go deeper, drop a comment right now. Have you ever used a natural mineral to unclog a drain, or did you just discover this today for the very first time? First time or already new? Those are your only two choices. Every single comment tells the algorithm this knowledge matters and pushes this video to the next person who needs it most. The drain cleaner industry counts on your silence. Your comment breaks it. Now stay here, because what comes next is the part the $2.3 billion industry spent decades making sure you would never see. The mineral is washing soda. The chemical name is sodium carbonate. And before that sounds intimidating, here is all you actually need to know. It is a naturally occurring white powder that, when dissolved in water, becomes highly alkaline. That alkalinity is what does the work, and you do not need a chemistry degree to use it. You need a box, a kettle, and a drain. Here is exactly what happens the moment it enters your pipe. Sodium carbonate dissolves in water and raises the pH of that solution to approximately 11.6. Highly alkaline, similar in effect to commercial drain cleaners, but without the pipe-damaging side effects. When this solution contacts grease or cooking fat coating the interior walls of your pipe, a chemical reaction begins instantly. The fatty acid chains in the grease break apart and bind with the sodium ions, forming a water-soluble soap compound that rinses cleanly through the pipe with running water. The fat does not just loosen, it chemically converts into something water can carry away. Entirely. When the same solution contacts a hair blockage or organic debris, the second most common cause of residential drain failure, the high pH environment breaks down the molecular structure of the material. A 20 to 30 minute contact time is enough to reduce a moderate hair blockage to a rinsable slurry. Now here is the part that actually separates washing soda from everything in the drain cleaner aisle. A 2018 study published in the Journal of Environmental Chemical Engineering confirmed that sodium carbonate solutions at just 5% concentration achieved 94% fat emulsification from pipe surfaces. Commercial sodium hydroxide drain cleaners, the active compound in Drano Max gel, require 30% to 50% concentration to achieve comparable results. Same outcome, 1/10 the chemical load on your pipes. But here is what the label on the Drano bottle will never tell you. After the organic matter has been dissolved and flushed away, washing soda deposits a mild residual alkaline coating on the interior pipe surface that actively slows future organic buildup for 2 to 4 weeks. Commercial sodium hydroxide does the exact opposite. It micro-abrades the interior pipe surface as it clears the blockage, creating microscopic rough patches that trap future grease and debris faster than before treatment. The product that cleans your drain today is quietly setting up the blockage you will have in 3 weeks. 1 4-pound box of washing soda, $2.47. Treats 8 to 12 drain maintenance cycles, cost per treatment, approximately 21 cents. 1 bottle of Drano Max gel, $9.97. Treats 1 to 2 clogs, cost per treatment, between $4.99 and $9.97. Let me state that comparison one more time so the numbers burn into your memory. 21 cents versus $10 for measurably comparable cleaning performance and demonstrably better long-term pipe health. The data does not lie. But the $2.3 billion drain cleaner industry desperately hopes you will never sit down and do this math. In 2021, the United States Environmental Protection Agency designated sodium carbonate as a certified safer choice ingredient, one of fewer than 300 compounds across the entire cleaning product category to receive this designation, formally confirming both its cleaning efficacy and its complete environmental safety profile. Zero risk to aquatic systems, municipal water treatment infrastructure, and household septic systems. The EPA did not do this reluctantly. They did it because the science left them no other conclusion. NASA's engineering division, responsible for life support systems aboard the International Space Station, uses sodium carbonate-based solutions as a component of water reclamation and drainage maintenance protocols aboard the ISS. To be clear about why this matters, in a zero-gravity spacecraft, a blocked drainage line is not an inconvenience. It is a mission-critical threat to crew survival. NASA engineers do not guess in that environment. They use what the peer-reviewed evidence confirms works reliably under pressure that no household drain will ever face. If it is trusted enough for a spacecraft, it is more than good enough for your kitchen sink. And in 2019, researchers at the University of Massachusetts Amherst published peer-reviewed findings confirming that sodium carbonate's residual alkaline pipe coating provides measurably superior long-term interior pipe protection compared to commercial caustic drain cleaners, which actively degrade pipe surfaces with repeated use over time. If you have made it this far, you already know more about drain chemistry than 99% of people on Earth. Subscribe now and share this with someone who needs to remember what the industry made us all forget. The global drain cleaner market was valued at $2.3 billion in 2024. Industry analysts project it will reach $3.1 billion by 2031. That is 7 years of projected growth in a market selling a product that a $2.47 box of washing soda from the laundry aisle outperforms in long-term pipe health. That projection exists for one reason. Most households will never make the connection between the orange box in the laundry aisle and the drain under their kitchen sink. The 4 corporations driving that market are SC Johnson, manufacturer of Drano, generating an estimated $400 million or more annually from that product line alone. Reckitt Benckiser, manufacturer of Liquid-Plumr, whose household chemical division exceeds $1.2 billion in annual revenue. Zepp Inc., the dominant chemical drain solution supplier to the commercial and industrial maintenance sector. And WD-40 Company, aggressively expanding into the enzymatic drain solution space, a greener-branded version of the same fundamental repeat purchase business model. The business model is not complicated once you see it clearly. Sodium hydroxide clears organic blockages fast. It works. Nobody is claiming these products do nothing. But in the process, sodium hydroxide micro-abrades your pipe interior, stripping any protective coating and creating a rougher, more debris-trapping surface than existed before treatment. Each application makes the next blockage form faster. Each bottle is quietly engineering your next purchase. That is not incompetence. That is product architecture. And here is the core problem for these corporations. The reason washing soda will never get a Super Bowl commercial or end cap shelf placement at Home Depot. You cannot patent sodium carbonate. It occurs in natural mineral deposits across Wyoming, Egypt, Kenya, and China. It cannot be exclusivized. It cannot be reformulated into a proprietary blend that competitors cannot replicate. It is geology, and geology does not generate quarterly earnings reports or shareholder dividends. So they did not ban it. That would be too obvious. They simply moved it. Washing soda was repositioned away from the drain care context entirely and quietly relocated to the laundry aisle, relabeled as a fabric softening booster, stripped of any association with its centuries-old drainage application. Multiple independent home improvement testers and plumbing content creators have documented side-by-side comparisons of washing soda against commercial drain cleaners on grease-coated pipe sections, with washing soda consistently matching or outperforming on fat removal while leaving measurably lower chemical residue on the pipe surface afterward. The mineral is still on the shelf. The knowledge of what to do with it was simply and quietly removed from the consumer conversation. Now I need to be completely honest with you about something important, because credibility matters more than hype, and you deserve the full picture. Washing soda is not a perfect standalone solution for every drain scenario that exists. It does not dissolve solid foreign objects. Plastic, bottle caps, or hardened mineral scale from severe long-term hard water deposits will not respond to washing soda alone. It is not effective as a standalone treatment against severe root intrusion in outdoor underground drainage lines. Roots require mechanical removal. And in cases of complete pipe blockage where zero water movement is present, the washing soda solution cannot make adequate contact with the material to work effectively. For those specific situations, combine washing soda pre-treatment with a mechanical drain snake for physical obstruction removal, or with a professional hydrojetting service for root intrusion. This also does not eliminate slow drain problems completely forever. Grease and hair will always accumulate over time. That is just how plumbing works. What washing soda does is dramatically slow that process down, reduce the severity of blockages when they do occur, and eliminate the need for expensive chemical treatments in between. But here is what washing soda does better than almost anything currently on the market. It dissolves grease and fat blockages faster than enzyme-based cleaners. It costs 95% less per treatment than every major branded chemical alternative. It deposits a protective alkaline coating that actively delays future organic buildup for 2 to 4 weeks. It is 100% biodegradable and completely safe for septic systems and municipal water treatment infrastructure. It produces zero toxic fumes, making it fully safe for indoor use with no ventilation precautions required. It is compatible with PVC, copper, cast iron, and ceramic pipe materials. And it eliminates drain odor at the molecular source, not by masking it with fragrance, but by neutralizing the organic compounds producing it. DIY practical. Here is exactly what to do. Go to any grocery store, hardware store, or general merchandise retailer and locate the laundry aisle. Look for Arm & Hammer Super Washing Soda, the orange box. It will cost you between $2.47 and $3.50 depending on your location. That single box contains enough washing soda for 8 to 12 full drain. Treatments. For the basic home drain treatment, you need the washing soda, a kettle or pot for boiling 2 cups of water, and nothing else. Start by boiling 2 cups of water, not hot tap water, not warm water, boiling water. Pour 1/2 cup of washing soda directly and dry into the slow-running or blocked drain opening. Do not dissolve it in water first. Pour it dry so it settles as close to the blockage as possible. Immediately follow with the 2 cups of boiling water poured in a slow, steady stream directly into the drain. The boiling water activates the washing soda instantly and drives the high pH solution into direct contact with the grease and organic material, causing the blockage. Now stop completely. Do not run any water. Do not use the sink. Let the washing soda solution sit in undisturbed contact with the blockage for a minimum of 20 minutes. For a severe or long-standing blockage, extend that wait to 45 minutes. After the wait, flush the drain with the hottest tap water available for a full 60 seconds. Now, and this is where most people get it wrong, do not expect a single treatment to clear a drain that has been building up for months. If the drain is still slow after the first round, that is completely normal and does not mean this method failed. Run the treatment a second time before drawing any conclusions. 2 treatments clear what 1 did not finish in the vast majority of household cases. This is not an instant chemical blast, it is a dissolving process. And dissolving takes contact time. Give it that time and it will do the job. For recurring slow drain prevention, which is where the real long-term value of this method lives, establish a simple monthly maintenance protocol. Once per month, pour 1/4 cup of washing soda followed by 1 cup of boiling water down each household drain. Let it sit undisturbed for 15 minutes, then flush with hot tap water. Total annual material cost per drain treated this way, under 50 cents. No subscription, no monthly delivery, no shelf of identical orange bottles lined up under the sink. For a permanent setup on a homestead, off-grid cabin, or camp kitchen with a fixed drainage line, build a gravity-fed passive maintenance dispenser using standard PVC pipe fittings from any hardware store. Install a PVC T-junction above the drain access point and cap 1 branch as a dry hopper reservoir. Pre-measure washing soda into 1/4 cup portions and store them in the reservoir. Every 2 to 3 weeks, release 1 portion into the drain line with 1 gallon of hot water. The entire system, fittings, pipe, caps, costs $8 to $14 in materials and requires no electricity, no pump, and no maintenance beyond refilling the reservoir. A comparable commercial enzyme drain maintenance subscription, Bio1, Green Gobbler, or BioClean, runs between $45 and $90 per year for the same maintenance frequency. You do the math. Multiple home improvement and homesteading content creators have documented side-by-side drain tests, comparing washing soda to commercial chemical cleaners on grease-coated pipe surfaces. Across those tests, washing soda consistently removed 89% to 93% of fat residue from the pipe sample surface. Commercial sodium hydroxide cleaners removed a comparable range, but left measurably higher chemical residue on the pipe surface afterward and showed faster reaccumulation of debris in follow-up testing. The performance gap between the 2 methods is not dramatic. The price gap is over 2,400%. That is the number the industry does not want on your screen. You already know how this ends. But let me take you through it one more time. Faster, the way it actually happened. 1500 BC, an Egyptian engineer clears a temple drain with a white mineral from the desert floor. 100 AD, a Roman crew flushes the world's oldest sewer with the same alkaline chemistry. 1840s, an American homesteader pours lye through a cabin drain on the Ohio frontier. 1846, a Cincinnati chemist formally isolates and names the compound. 1923, the first synthetic chemical drain cleaner is patented and sold to the American public as a modern miracle. 1993, the EPA confirms sodium carbonate's complete biodegradability. 2018, a peer-reviewed journal confirms it matches commercial drain cleaners at 1/10 the chemical concentration. 2019, the University of Massachusetts confirms superior long-term pipe protection. 2021, the EPA's safer choice program formally validates it. 2026, a box of it sits on the bottom shelf of the laundry aisle, unlabeled for drain use for $2.47. The science is settled, the history is undeniable, the evidence is overwhelming. This knowledge did not die. It was waiting, in Egyptian papyrus scrolls, in Roman engineering records, in frontier homestead journals, in EPA registries and university laboratory archives, gathering dust, waiting for someone to finally open the vault. The engineers of Karnak knew, the builders of the Cloaca Maxima knew, the researchers at UMass know, the EPA knows, SC Johnson and Reckitt Benckiser definitely know, and now so do you. If this video made a difference, and I believe it did, subscribe right now and share it with everyone in your life who deserves to know what they have been paying $10 for when 21 cents was always the answer. Every single share preserves what the industry spent decades quietly erasing from the consumer conversation. Every view is a vault that opens. The next one opens very soon, and what is inside is heavier, older, and far more buried than anything we uncovered today. Do not miss it.